Hello there. This video is entitled Module 1 Heart of Algebra Section 1. This video was produced by Shanice Musgrave of I Am Legacy International. I would have already gone through several introductions and tips in previous videos, so let's get straight into Section 1. Before that, I would just rehash some facts about the Heart of Algebra section. The Heart of Algebra section on your SAT makes up 19 questions out of the 58 questions you have in total, which is about roughly 33% of the entire math section. 11 in your calculator section, which is section 4, and you have 8 in your no calculator section, which is section 3. Please be advised that most of your questions on the SAT are multiple choice questions, but in the math section you have a few grid questions, or we call it student produced questions. Also note that the concepts of Heart of Algebra are used to analyze and solve real-world problems and scenarios. So at this point, I would like you to ensure that you have all your writing material and stationery out, ready to take notes. Please note that whatever materials I am using in this video, for the most part, especially the PowerPoint, would not be provided to you separately, as it is teaching notes and it would be used for other copyright purposes coming soon. So what I'd like you to do is to ensure that you capture everything as much as possible, because the information is pretty simple. By whatever means you would like to record or save this information, it is up to you. And so let's get straight into section 1, linear equations. What is a linear equation? A linear equation is the equation of a straight line. I'm sure most of us at some point in our academic journey, especially in our math journey, we would have encountered linear equations. Linear equations are more or less two variable equations, and those variables are x and y, and we'll look at those further later on. There are two forms of expression for linear equations. You have one, the slope-intercept form, which is the most common for SAT, and then we have number 2, which is your standard form. So let's take a quick look at the standard form. You will not often see the standard form. You would more so be using the slope-intercept form, but the standard form says ax plus by is equal to c. This is where a, b, and c are numbers, I would say. The a is the coefficient of x, and the b is the coefficient of y, and the c is what would be produced. So let's look a little further. If we were to make y the subject of the formula, what we are saying is we are trying to convert the standard form into the slope-intercept form. So just over here, you'd realize that the slope-intercept form, which is here in example 1, it's y equals mx plus b. For some of us in the Caribbean, we would have been accustomed to y equals mx plus c, but it's all the same. So let's go back over to the standard form. It says if we make y the subject of the formula, then we would get a over b x plus c over b, where minus a, sorry, I forgot the minus, where minus a is the slope and c over b is the y-intercept. So let's go into this slope-intercept form, and then I'll work this out for anyone who cannot clearly see how we converted the standard form into this slope-intercept format. So again, the slope-intercept format is the most popular form in your exam, and that's y equals mx plus b, where x and y are your two variables, m is your slope, and b is your y-intercept. This other example just shows where the y-intercept comes first, but you realize nothing changed. They just swapped it, so it's basically the same. So I'll go to the board now, and we would write down, so this is your slope-intercept. This is your slope-intercept format. Let me ensure, oops, I need to get my pencil. That's what it is. So this is your slope-intercept form, right? Please excuse my handwriting if it's not perfect. Slope-intercept form is y equals mx plus b. And our standard form, as we had seen earlier, is ax plus by is equal to c. Let's try to get this into the y-intercept form. So the first thing, if you remember your basic algebra, the first thing would be to get rid of this term here, this x term, because we want y to be the subject of the formula. So what we'll do is ax, we will minus ax from both sides. So once we minus ax from both sides, this is what you would get here, right? In order to get rid of a positive ax, we would have had to minus ax. That will cancel out as 0, and we will minus ax on the right. So remember, from basic algebra, whatever you do on the left, you do on the right, and vice versa. So if I want to make this look very close to the slope-intercept format here. So what I'll do is I'll just do a switcheroo, which says by is equal to minus ax plus c, just for perfection purposes. And then how do we get y to be the subject of the formula? Well, what we need to do is divide both sides by b. So to get rid of this, I would say by divided by b equals a minus ax plus c, the all divided by b. So when I say b into b, it's 1, and then it will be y is equal to minus ax over b. Each term is obviously over b, plus c over b, where we know, or we have our x and y variables, and whatever is the coefficient of x now becomes your slope. So in this situation, your slope is minus a over b, and then this entire number here, whether it's a fraction or a whole number, whether it's negative or positive, represents your y-intercept. So I wanted to ensure that we understand how to convert the standard form into the slope-intercept form, because sometimes on the SAT you may get a question where it's in the standard form, and in order to work it out or to get what you're really looking for, you may have to convert it to the slope-intercept format. So that is very, very important. So moving along, okay, before we move on, let's look at an example. So what if we had an equation, let me just change the color. What if we had an equation that says y is equal to minus 2x plus 5? We know we have our y and x variables, and we know in this case our slope is negative 2. So we can safely say m is equal to negative 2, and our this 5 is actually our b, which is what? Your y-intercept, right? And what about this other example where we have y is equal to 10x plus 6? Our 10 will be m, our slope, and our 6 would be b. Good? So by now we should all be getting a hang of this. What if we had y equals 7/8x plus 8 over 9? What is our slope? 7/8, and 8 over 9 is our y-intercept. So we're looking at some examples or easy ways of identifying your linear equation in your slope-intercept format, and you must also be able to identify it in your standard form. Great. So let's move on to the other slide. In this slide, what we're doing here is breaking down your slope-intercept format, which is your y equals mx plus b, whereby m is your slope, and for most of us from the Caribbean, we would have learned gradients, and more often seeing the word gradient as opposed to seeing the word slope. So that's no problem, but the SAT, slope will be the terminology to use. And what is slope basically? So slope, I have a variety of ways of describing slope. Slope is y2 minus y1 over x2 minus x1. And what is that? y2 minus y1 over x2 minus y1. What does y2 minus y1 stand for? It stands for the vertical distance, because as you would see right here on these graphs, we know this vertical axis represents what? Vertical axis represents your y-axis. So therefore y2 minus y1 represents your vertical distance, and we know this horizontal axis is your x-axis, where x2 minus x1 represents your horizontal distance, or as we learn it, rise over run, right? Or the change in y over the change in x. So basically, these are just simple ways, all of repeating ourselves to mean the same thing. So all meaning the same, just repeated in different ways. So we are seeing an example here where you have a visualization of the rise and the run of the slope. So right here is the rise, where you have y2 minus y1, and then right here you have the run, which is the x2 minus x1 of your slope. Good. And then you can take some time to pay a little attention to this graph here. It's a video, so you can pause it at any point in time. What we're also going to look at now is your b, which is equal to your y-intercept. And what is the y-intercept? This is the point at which the line passes through. I missed out here. The point at which the line passes through the y-axis. So let's put that in right now. Or I am not sure why I had this. So it's the point at which it passes through the y-axis. That was a typo, where x is always equal to 0. So we see an example right here. It is the point at which it passes through, the line passes through the y-axis, and where we see here our x is 0 and our b, it represents that point on the y-axis. Good. So you can take a look at this. This is basically your y-intercept in a nutshell. And then we have the x and y. Remember, I told you earlier they are variables, where the x represents an input value of a function, and we say that's independent, and the y is the output value of a function, which is a dependent variable. And we'll look at this shortly. Note that x and y variables are only raised to the power of 1. So if they are squared, cubed, then they are no longer linear equations. Okay, they would no longer have linear properties, and they can never appear in a denominator of a fraction once linear. So those are very important properties. And also, all points that make the linear equation true lie on the same line. Very, very important. So let's quickly look at what you call a relationship between independent and dependent variables, right? So as I'm speaking and as I'm erasing this whiteboard here, I'd like you to start thinking in your mind, what do you think independent and dependent variables would stand for? So let's look at an example. So we have y is equal to mx plus b. And I'm going to elaborate a little more and give you an example where you have y is equal to 2x, right? So I'm just leaving the b alone for now. What we want to determine is which one is independent and which one is dependent. I'm just putting this for short, independent and depend. Okay, which is independent and what is independent? So if I plug in a value for x, let's say the value for x is 4, I will get y is equal to 2 times 4, which is equal to 8, and my y value is 8. This tells us that without a value of x, without a value of x, we do not know what y is. So what this means is that y depends on x. Therefore, our dependent variable is y, and our independent variable is x. X is in no way dependent on y, but y is dependent on x because we need an x value in order for us to find the y. So that just more or less explains the idea of independent versus dependent scenarios. We have different type of slopes that we should look at this point. We have a situation where we have this graph here and it has the x and the y axis, so it's all on a coordinate plane, And we have 4 lines in particular. We have line N, we have line L, we have line M, and we have line K. So line N, which is this line here, describes a positive slope. Why does this describe a positive slope? And it's because it rises uphill from left to right, which makes your slope positive. So it's as if you're going uphill, okay? And then line L describes a negative slope because it falls downhill from left to right. And we have line K, which describes a line with no slope, or we can say the slope is 0. Slope equals 0 just means no slope. And this is a line that is parallel to the x-axis. And finally, we have line M, which describes a line with an undefined slope because it's parallel to the y-axis. Usually their slopes cannot be calculated numerically. So on the SAT, it would be in your best interest to be able to identify the different types of slopes in either a graph type question, a question that gives equations, or even a scenario based question where you have to convert English to math. So we have line N, which is positive slope, line L, which is negative slope, line K, which has a slope of 0 or no slope, and then line M, which has an undefined slope. Please know that everything I go through in this video is mandatory, because on your exam you would have theoretical type questions where they expect you to know these definitions and these explanations. You do have some questions where you don't even have to touch a calculator or even jot down calculations. It will be a theory based question to see if you know your theory. And then I have the same slopes, just more or less elaborated. Here we have slopes of horizontal lines, which is like your line K there. It has a slope of 0. And then we have slopes of vertical lines that are undefined, which is like your line M. And then we have slopes of parallel lines are equal. This is very important to know. Once you have parallel lines, their slopes are always equal. So that's a good way to identify a parallel line. If they give you 2 equations and you realize the slope is the same, you know for sure that is a parallel line. And then we have slopes are negative reciprocal. So slopes of perpendicular lines. This is a perpendicular line here, a line that looks like a cross where you have a 90-degree angle. They have negative reciprocal. So if the slope of the blue line was 5/3, then the slope of the green line would be a negative 3/5. So please go back and rehash or revise what a reciprocal is if you did not remember at this point. What does slopes tell us? Slopes tells us the rate of change, and this is the application of slope on your SAT. Very, very important. So slopes often tells us the rate of change of something, whether it's something is increasing or whether something is decreasing. If a line has a large slope, it indicates rapid change. This is extremely important. And if a line has a small slope, it indicates gradual or slow changes. Note, a positive slope signifies an increase in a variable, and a negative slope signifies a decrease in a variable. Repeat after me. The steeper the slope, the greater the rate of change. So large slopes that indicate rapid changes are very steep slopes. These are, I'll just put an equal sign here, these are the steeper slopes, right? And then obviously small slopes are not as steep. So this is something I remember learning in school. The steeper the slope, the greater the rate of change. So the steeper the slope, it tells us that the value is larger and the rate of change is rapid. Let's look at some diagrams. So we have diagram here. I will just go to the graph and draw for you. So let's say we had 2 lines here. One going uphill like this, and the other going like this. So this is line A and this is line B. Which slope is steeper than the other? That's what we want to look at here. Which slope is steeper than the other. So I'll give you a minute, just think about it. Consider this, I'll give you a hint. Consider ultimate steepness to be the y-axis. I always say that to help my students understand what is steepness, right? Just consider ultimate steepness to be literally a line that's almost as vertical as the y-axis. So therefore, as the lines draw closer to verticality, then that is your steeper line. So by now you all should recognize that line A is your steeper line. So therefore it will have, so this is your steeper line, so therefore it will have rapid change. And because it has rapid change, it means that your slope, you have a larger slope than line B. And what else I'd like you to deduce from this line is that because this is a positive slope, this is a line running uphill from left to right, we are speaking about rapid increase in this scenario here. And because B is not as steep, it will show small or gradual. I wanted to use the word slow, small or gradual or slow change. And because this is also running uphill, it's a positive slope, so therefore it is going to signify increase. It means that the increase is slow or gradual. So this is what I want you all to get out of that. So take some time and kind of ingest that. I want to be able to give you another scenario of a negative slope. Let me just erase this side. As I erase, you can pay attention to that coordinate plane with those slopes while I would just draw the negative lines, let's see, outside of the grid. So here we go, here, there. I'll just make this like my, oops, sorry for the, I'm drawing graphs and my lines are not straight, so forgive me. So this represents line C and line D. I'd like you to tell me which is steeper. Now these lines, one thing you should note is that they are running downhill, so therefore they are negative slopes. They have negative slopes, and the line that's steepest is your line. Everybody should be repeating now or saying it all together. We all should get this right. Our steeper line is line C. So what does the steeper line show? It shows rapid change. Oops, sorry about that. So it shows rapid change. How do I get rid of you? Yes, it shows rapid change. And in this case, because we're dealing with negative slopes, we are talking about decrease. Okay, so this is a line C shows what you call a rapid decrease, whereas line D shows a gradual or slow decrease, right? So by now we should all get the hang of this. And let's move on quickly. I have an application video, an application slide here. So by now I would also like you to consider other application and examples and make your own analogy. So here I have this guy, what is he, skateboarding, and they are showing the steepness. Obviously he's going downhill, or maybe he's going up, I'm not sure. But here we are seeing a steeper ramp versus a not so steep ramp. So in this case, you'll have a larger slope versus a smaller slope. And then in this case, we have this very interesting looking animal. He says, whoa, this is easy when the slope is negative. Downhill, baby. That's funny. But that is a nice application. So you want to send something downhill, it will get down there faster if the slope is steeper. I love it. And then we have a zero slope, which is a flat horizontal. So remember, horizontal lines or horizontal directions have a slope of 0. So in other words, no slope at all. And like I said, I'd like you all to consider your own examples and your own mnemonics and analogies for remembering these slopes. The other thing that's very important, maybe you can take this, pause the video and write this down. These are, this is word problem conversion table. These are words that means all of these operations here. So we have the equal sign, you have the obvious equal, is, equivalent to, was, will be, has, cost, adds, up to, the same as much as, all those mean equal. So once you see it in a worded problem and you have to convert English to math, you know what signs or operations to use. And then for multiply, we have the obvious one, times of, multiplied by, product of, twice, double by. Divide, we would have divided by, per, out of each ratio. Plus, we would have plus added to, and sum, combined, total increase. For minus, we would have obviously subtracted from, smaller than, less than, fewer, decreased by, difference between. And then for X or N or any other letter, you will have them say a number, how much, how many, what, or they might call a person name, or they might call a fruit or something that you're purchasing, and then they will say, okay, how much of this, how much of that, and that type of thing. So at this point, you can take this down, and then I would now like you to consider a scenario here. And in consider, I am saying this to you, consider this. You open your first savings account at Scotiabank, and after a few months you wanted to check up on your balance. The balance in your account is B, and it changes over the days D that go by. Consider, I feel I might have some English errors here, but anyways, consider, discuss and describe the following models of your account and state which one you favor the most. So we have case 1 where B is equal to 120 plus 80. We have case 2 where B is equal to 0.20D plus 80. Case 3, B is equal to negative 120D plus 80. And case 4 where B is equal to negative 0.2D plus 80. So I'd like you for a moment to pause the video and consider, discuss, describe the following models of your account and state which one you favor. So maybe pause the video for about let's say about 2 to 3 minutes or even 5 minutes. Consider it before you continue the video, because now I am going into the explanation of what is going on here. So I'll really like you to pause the video, do it, and then press play again and look at the explanation. So I am going here now. So by now I'm expecting that all of us would have paused the video so that you can consider your cases before you look at what I had to say about those situations there, right? So that by now you should have done that. So we're looking at case 1. Case 1 is B. Case 1 is B is equal to 120D plus 80. What you all should realize in each case is that what is common about each case? That's what I want to ask. And by now, you all should kind of look down at your book and shouting it at the video, although I can't hear you. What is common about each case? What is common is the, obviously, 80. And what does 80 represent? I would like you to shout it at me now as well. Good. So 80 represents $80 that you started your account with. So you started your account. So I'm just going to put start up. So you started your account with $80, and we know by now D represent days. So what does this mean? Over a particular number of days, which we don't know, you get $120 per day. So we're talking about this 120 represent $120 multiplied by days. And remember, we don't know how many days we're looking at. So it means that one per day you are receiving $120. So what type of account this is? This is a really great account. This is an account that will make you ecstatic, in other words. And then, our case 2, we are looking at, you started the account with $80, and then by per day, you are getting 20 cents. Is this an account to smile about? Maybe not. Maybe this might be a slow, maybe you may have enrolled in some sort of business, and and per day you're making 20 cents. Not so great. I think all of us might prefer the case where we're getting 120 a day, and we did not even discuss what currency. So this could be 120 US, this could be 120 pounds. So the first account is, I am sure for all of us, is the most favorable account. And then account 3, it's this, what's going on here? We have a negative value. So this means every day you're losing $120 by the day. Now this is called for screaming. This means that you are bankrupt, my friend. I don't know what you're doing, but somehow by the day you're losing $120. This is bankruptcy. And then in case 4, you are losing 20 cents a day. It's not quite bankruptcy. This could be a case where maybe a bank teller, the bank is pulling out 20 cents from your account and hundreds of other people's account by the day. And by now, you should be quite concerned if you're going to check your balance and you realize, wait, by the day, I'm losing 20 cents. So this should raise some alarm because you don't want that 20 cents to turn into dollars. Good? So what I like to go back and rehash about this is what you call a linear situation where B can be your Y, right? Where 120 is your M, your slope, and D is your X, and that 80 represents your y-intercept. So this is how they use scenarios to mimic your linear equations, and these are the applications of linear equations. So they might ask you, in this banking scenario, what is your slope? And you know your slope is 120 or 20 cents or negative 120 or negative 0.2, negative 20 cents. In this case, what type of increase, what type of slope we have? We have a positive slope, right? So therefore it means rapid increase. And in this case, we do have a positive slope, but it's a very small slope. So therefore it is what you call a slow or a gradual increase, right? So this is where I want you all to be able to apply the theory to the real world scenarios. And then in this case, what do we have? By now you all should be shouting it back at me. This is a rapid decrease, right? Very negative. And so in other words, very steep. And in this case, what we have is a gradual, it's a gradual decrease. Okay, so that's the applications that I would like us to pay attention to at this point. So on my other slide, I more or less kind of went into the facts. So you started your account with $80 and D represents the days. This account is what you call a favorable account because every day you earned 120 on top of the $80 you started with. And then account number 2, not so great because you only earn 20 cents per day. Who wants that? And then case number 3, you're bankrupt. Something major is happening here. You're losing $120 per day. No bueno. And then your case 4, raise of concern because you're losing 20 cents a day. Maybe a bank teller is withdrawing 20 cents per day on the DL to make a run for it. And you gotta catch them, right? So in this, that's me more or less answering those cases. So everything that this is where you compare your initial thoughts on it, and I would like you to know now, this is how you can look at your y equals mx plus b, where m is your slope, which is rate of change, and B is your initial output. So in this case, your initial output is $80, and then X is inputs, and then Y obviously is output. So when you calculate all of this and you put your input in, you shall get an output. Great. At this point, I would like to let you know that your goal for now is 1 minute per question until you can do 30 to 45 seconds per question. Please complete all the suggested questions. I would have listed questions here on page 42. Can you do number 7, number 9, and on page 42, number 10? If the questions change, there would obviously be a note right after this video listing to you all the questions that you should engage in. Thanks for listening. I hope that this would have clarified some things for you on linear equations, and see you in the next video. which is based on systems of solutions. Bye-bye.